Hello and welcome to the Tarmac virtual event on sustainable construction. My name is Spencer Tubb and I am the Commercial Manager for Chryso UK. Since 1942, Chryso has been a global leader in admixture technologies. We have over 1,300 employees, 34 industrial sites and a presence in over 100 countries. 20% of our staff work in R&D. 35% of our turnover are generated thanks to products which are under 5 years old, and 3% of our turnover are invested every year in R&D. We have been a leader of construction chemicals in the UK since 1997. Being one of the first companies to invest in their own polymer reactors has enabled us to be at the forefront of admixture polymer advancement. Through this, we have been working closely with Tarmac to be the leader in sustainable construction solutions. The agenda is cement reduction, supplementary cementitious materials, concrete consistency, Grand Paris Tunnel, challenging materials, Tottenham Hotspur Stadium, and driving sustainability. Sustainable construction. We have taken a cradle-to-grave approach on the construction industry to find new ways we can help improve sustainability, whether that is to improve a building's design life, improve durability and robustness, or allowing concrete mixes to utilise recycled materials and repurpose waste materials from other industries. We provide solutions which combine both low carbon and high performance technologies. Our admixtures and services enable Tarmac and the construction industry to focus more and more on environmentally efficient concrete designs without affecting usability. Cement reduction involving admixtures. One of the first areas to look at for reducing CO2 is the use of cement. Concrete has a relatively low carbon footprint compared to other industries, but it is one of the most widely used construction materials. The addition of admixtures has enabled a reduction of the cement content in concrete, reducing its carbon footprint. For many years, water-reducing admixtures have been used to improve water-cement ratio of a mix. This increases the concrete strength, enabling a reduction in the amount of cement required. Admixtures have evolved to be more powerful, offering greater water reductions. Traditional lignosulfonate admixtures gave a water reduction of around 10%. Today's polymers can reduce water by up to 40%, therefore allowing even greater reductions in cement, but still offering the required concrete performance. Supplementary cementitious materials. SCMs, or supplementary cementitious materials, are byproducts from other industries. These materials give other benefits to concrete, such as chemical resistance, but also have strength-gaining properties similar to Portland cement. These materials change the chemistry of the concrete mix, so specially developed admixtures are used by Tarmac to ensure the rheology and technical performance are still maintained. This allows the CO2 footprint of mixes to be substantially lower than traditional CEM1 designs. The most common of these SCMs in use today is GGBS. This is a waste product from the iron industry and, depending on requirements, can replace anywhere from 20 to 95% of the CEM1 content. Concrete consistency. Tarmac's use of Chryso's latest admixtures allow the concrete's consistency to be maintained for up to 10 hours. This ensures that deliveries will not be rejected at site, saving time, money and pollution. So why is this important? A vitally important aspect of the mix design is to ensure that the concrete arrives on site at the same consistency as it was batched. This can be difficult to achieve if the correct admixtures are not used and the load is delayed by traffic or the job site. This means loads may be rejected and returned back to plant. This is not only a financial problem but also increases pollution with the extra loads being trafficked. The Grand Paris Tunnel was a group of new rapid transit lines. The project comprised of new lines plus extensions to existing lines 11 and 14. A total of 200 kilometres of new track and 68 new stations were added, serving a projected 2 million passengers a day. It was the largest urban project in Europe, involving Chryso in partnership with Tarmac's parent company, CRH. In order to minimise traffic movements and prevent rejected loads, concrete with a low viscosity and a workability of up to 10 hours was required. This was achieved using Chryso's Optimal 1000 series technology. Challenging materials. Although aggregate and sand are two of the main constituents in concrete, the materials must be of particular type, shape and particle size. Without this, the concrete may not achieve its design strength and consistency. This means that quarries that have stockpiles of materials that are considered low value because they are unusable in concrete. To overcome these issues, Tarmac is now utilising Chryso's Quad range of admixtures. Using Quad technology means that low value materials that suffer from swelling clay, shape factor, absorption or problems with fines can be re-engineered to work with concrete. This maximises the use of local aggregates, negating the need to transport materials from further away. Tottenham Hotspur Stadium. The new Tottenham Hotspur Stadium commenced its build in 2015. Tarmac supplied the ready-mix concrete for the project. During the piling stage of the build, rather than use fresh virgin aggregate, excavated material from the site was repurposed using Chryso's Quad 20 admixture for 14,000 cubic metres of the concrete. This not only saved considerable time and money, but also reduced an estimated 12,000 truck movements. Chryso and Tarmac drive sustainability for the future. Chryso believe in a sustainable construction cycle, and we utilise this ethos to help Tarmac achieve their sustainability goals. Our sustainability pillars are reduction of carbon footprint, reducing CO2 in cement and in concrete whilst improving overall energy efficiency. Densification of construction, the ability to deliver concrete with the correct specification wherever it is needed. Enhancing building materials, giving concrete properties that are most suitable for its environment, whether that is pumping long distances or overcoming transportation issues. Circular construction, the use of admixtures to enable the use of recycled materials, local challenging aggregates, and wastewater treatment and capture. Chryso and Tarmac working for a sustainable future.